So we are going to see data link layer. This data link layer is having two sublayers. The first one is the upper sublayer, which is responsible for data link control, and the upper sublayer that is responsible for flow and error control is called logical link control sublayer. So there are two sublayer, that is logic link control sublayer and MAC sublayer. Of this upper layer is called logic link control sublayer, and which is responsible for flow and error control. The lower sublayer is responsible for resolving access to the shared media. When more than one device is connected to a link, then some mechanism should be there for access. So the lower sublayer, that is medium access MAC sublayer, it will the multiple access resolution, it is done by medium access control layer. So two sublayers are there. One sublayer is called logical link control sublayer, another one is medium access control sublayer. So this is the two layers, logic link control layer and multiple access resolution, that is nothing but MAC sublayer. So for a dedicated channel, the lower layer is not needed. Okay. So if more than one devices is connected to a link, then this MAC layer is must. So in this multiple access protocols, there are three things, that is random access protocol, controlled access protocol, and channelization protocol. Three things you are having. First one is random access protocol, second one controlled access protocol, and the third one channelization protocol. In a random access protocol, we are having Aloga protocol, then carrier sense multiple access, then carrier sense multiple access with the collision detection, and then carrier sense multiple access with the collision avoidance. Now we are coming for controlled access protocol. We are having reservation, pooling, and token passing. These are the three things that we are having in the controlled access protocol. What are the three things? Reservation, pooling, and token passing. When you are coming for channelization protocol, we are having frequency division multiplexes, time division multiplexes, and code division multiplexes. Now we are going for random access. In random access or contention method, no station is superior to another station and none is assigned the control over other. Okay, the another name of random access is contention method. So in such a method, no station is superior to the another station and none is assigned the control over the other. No station permits or does not permit another station to send. At each instant, a station that has data to send uses a procedure defined by the protocol to make a decision on whether or not to send. If at any time a station is having some data, then the protocol will be having a procedure. Depending upon that procedure, it will send or it will not send. Two features given to this give this method this name. Yes, first one is there is no scheduled time for the station to transmit. Okay, there is no scheduled time for a station to transmit, and the second one is transmission is random among the station. That is why this method is called random access. In the random access method, why this name means there is two important things. First one is there is no scheduled time for a station to transmit, and the second one is transmission is random among the station. So there is no rules to specify which station should send next, and stations compete with each other to access the medium. So there will be one medium. To that medium many devices will be connected and the stations will compete among each other for sending the data. So it is called as contention methods. If more than one station tries to send, then there is an access conflict, collision, and the frames will be either destroyed or modified. So in this method, if more than one station is trying to send at the same time, then automatically collision will come, and due to collision, frames will be destroyed. Multiplexes. What does mean by multiplexes? If more than one device is accessing the same link, then it is called multiple access. Next one, carrier sense multiplexes. Carrier sense multiplexes means the station sends the medium before transmitting. So before transmitting, the station will sense the medium. So it is called carrier sense multiple access. So type of carrier sense multiple access is carrier sense multiple access with collision detection. So this carrier sense multiple access with collision detection tells that the collision is detected. Next one, carrier sense multiple access with collision avoidance. So in carrier sense multiple access with collision avoidance, the collision is avoided. Next one, Aloha. Aloga is the earliest access method and it is developed in the University of Hawaii. So it was designed for radio wireless LAN, but it can be used on any shared medium. So in this method, there are potential collisions. There will be a collision during the transmission. Why? Because the medium is shared among the station. When the station sends data, another station may attempt to do the same at the same time. So there is a possibility of collision. So the data from the two stations will be collide and become garbled. Next one, pure Aloga. So in the Aloga, there are two Aloga. One is pure Aloga and another one is slaughtered Aloga. Okay, there are two Aloga. First one, the pure Aloga, another one, slaughtered Aloga. So in pure Aloga, whenever a station is having a frame, it will send. Since there is only one channel to share, there is a possibility of collision between the frames from different station. So in pure Aloga, the acknowledgement is important. Okay, the sender will rely on the acknowledgement from the receiver. So when a station sends a frame, it expects the receiver to send an acknowledgement. If the acknowledgement does not arrive after a timeout period, the station assumes that the frame has been destroyed and resend the frame. So if acknowledgement is not received, then it is timeout. Within the some time, if the acknowledgement is not received, the station assumes that the frame has been destroyed and it will resend the frame. A collision involves two or more stations. So if all these stations again trying to resend their frames after timeout, the frame will also collide. So when there is a timeout, what this pure Aloga is telling, it is telling the station to wait for a random amount of time before resending it. So this randomness will help to avoid more collision. And this time, this waiting time, we are calling it as back of time TB. So what is back of time? Back of time is nothing but the time that a station is waiting after a collision, and the time is a random time. So pure Aloga has second method to prevent congesting the channel with the retransmitted frame. So after trying for some maximum retransmissions, it will give up and it will try later. Okay, two methods it is using in order to avoid collision. First one is it is using some random time. If any collision is occurred, it is waiting for some random time. Again, it is transmitting. That is the first thing. And the second thing, after taking some 2 or 3 chances, it will, or maximum chances, it will give up that transmission and it will try after some time. So this is pure Aloga. So here, you are having 4 stations and the 4 stations are sending frame. So first, each station is sending 2 frames. Each station is sending 2 frames. Now, the second frame of the first station is colliding with the first frame of second station, and first frame of third station, and first frame of fourth station. Similarly, the second frame of second station is colliding with the second frame of fourth station. Okay, so here only the frame 1 and frame 1 of station 1 and frame 2 of station 3 are not getting collided. So this is a procedure for pure Aloha. First, the station has some frame to send. So first it is setting k is equal to 0. That is the first attempt. First initializing the attempt is equal to 0. Then you are sending the frame. After sending, it is waiting for a time of 2 into TP. TP is nothing but the maximum propagation time. After that, it is waiting for an acknowledgement. If the acknowledgement is received, no problem, it is success. If the acknowledgement is not received, it is incrementing the attempt. It is incrementing the attempt and it is checking whether the maximum attempt is reached. If the maximum attempt is not reached, again it is waiting for some random time. It is waiting for a random propagation time. Then again it is sending the frame. So this is nothing but the procedure for pure Aloga. Okay. So now we are going to see the vulnerable time for pure Aloga protocol. Here the vulnerable time for pure Aloga is 2 into TFR. TFR is the average transmission time for a frame. So here average transmission time. This period is nothing but the average transmission time. That is T minus TFR to T plus TFR. This is the average transmission time. So the vulnerable time of this Aloga protocol is 2 into TFR. So throughput for pure Aloga is S is equal to G into e to the power minus 2G. So throughput for pure Aloga is S is equal to G into e to the power minus 2G. So what is G? G is nothing but the average number of frames generated by the system during one frame transition time. Okay, during one frame transmission time, how many frames are average number of frames are generated? That is nothing but the G. So the maximum throughput is nothing but 0.184 when the value of G is 1 by 2. Next one, slotted Aloga. So the pure Aloga is having a vulnerable time of 2 into TFR. So this is because there is no rule that defines when the station has to send. So whenever it is having data, it will send. So here in the pure Aloga, a station may send the data soon after another station has started, or another before another station has finished. So due to that, a collision is occurring. So in order to overcome these things, we are going for slotted Aloga. In order to improve the frequency, improve the efficiency of pure Aloga, we are going for slotted Aloga. In slotted Aloga, what we are doing is we are dividing the time slot into time into slot of TFRs. TFR is I think the average propagation times, and we are forced the station to send only at the beginning of time slot. So what you are doing in the slotted Aloga, we are dividing the time into slots of TFRs, and we are forcing the station to send only at the beginning of the time slot. So this figure shows the working of slotted Aloga. So here we are dividing the time slot. This is the first time slot, second time slot, third time slot, fourth time slot, fifth time slot, sixth time slot. During the first time slot, the station 1 is sending, and during the second time slot, second frame is station 2 is sending the first frame, and the station 3 is also sending the first frame. So here also there is a possibility of collision. So here in slotted Aloga, the vulnerable time is TFR. But in the case of pure Aloga, it is 2 into TFR. But in the case of slotted Aloga, it is TFR. Now, the throughput of slotted Aloga is S is equal to G into e to the power minus G. So when G is equal to 1, the maximum throughput is 0.368. So next one is carrier sense multiplexes. Carrier sense multiplexes is based on a principle sense before transmit. That is, before sensing, before transmitting, we have to sense the medium. If any other system is using the medium, so that we have to sense and then we have to send. In CSMA can reduce the possibility of collision, but it can eliminate it. The possibility of collision still exists because of propagation delay. When a station sends a frame, it takes time for the first bit to reach every station and for every station to sense it. So if any station is sending before receiving the first bit of that transmitted station, then the collision will occur. So here you are having 4 stations, station A, B, C, D. So at T1, A is sensing the station and it is sending the data. At the time T2, B will be sensing the station, and at the time T3, C will be sensing the station, and at the time T4, D will be sensing the station. Here in CSMA, the vulnerable time is nothing but equal to the propagation time. So in the CSMA, station may sense the medium and find it idle only because the first bit sent by another station has not been received. At the time T1, station B sends the medium and find it idle, so it sends a frame. So at T2, that is T2 greater than T1, the station C sends the medium and find its ideal because at this time first bit of from station B has not reached the station C. So C also sends the frame. So 2 signals collide and both frames are destroyed. I will once again explain. Here at a time T1, B is sensing the medium. At that time it is free, so it will transmit the data. Next, the time is T1. At a time T2, C will be sensing the medium. At that time, the frame which is transmitted by B1 is not reached C. So at this time, it will think that no one is using the medium. So C will also send the data and both will collide and the data will be lost. So in the CSMA, vulnerable time is equal to propagation time. So leftmost station A sends a frame at T1, which reaches the rightmost station D at the time T plus TP. This gray area, it shows the vulnerable area in time and space. Vulnerable time. So the vulnerable time for the carrier sense multiplexes is the propagation time TP. This is a time needed for a signal to propagate from one end of the medium to another. When a station sends a frame, any other station tries to send a frame during this time, collision will be happening. But if the first bit of the frame reaches the end of the medium, every station will already have heard the bit and will refrain from sending. So there are 3 persistence methods. The persistent method 1, non-persistent method, and P-persistent method. One persistent method means that it is simple and straightforward. In this method, after the station finds the lines idle, it sends the frame immediately. This method has the highest chance of collision because 2 or more stations may find the line idle and they send their frames immediately. Next one is non-persistent method. In the non-persistent method, a station that has a frame to send senses the line. If the line is idle, it sends immediately. If the line is not idle, it waits a random amount of time and then senses the line again. The non-persistent approach reduces the chance of collision because it is unlikely that two or more stations will wait the same amount of time and retry to send simultaneously. However, this method reduces the efficiency of the network because the medium will remain idle for some time. So next one is P persistent method. In the P persistent method is used if the channel has time slot with a time slot duration equal to or greater than maximum propagation time. So when P persistent method is used, this persistent method is used if the channel has time slots with a time slot duration equal to or greater than the maximum propagation time. So the P persistent method combines the advantages of other two strategies, that is one persistent method and non-persistent method. It reduces the chance of collision and it will improve the efficiency. In this method, the station finds the line idle, it follows these steps. If the line is idle, it will do the following step. With a probability P, the station will send its frame. With a probability Q is equal to 1 minus P, the station wait for the beginning of the next time slot and it checks the line again. If the line is idle, it goes to step 1. If the line is busy, it acts as though a collision has occurred and uses the back off procedure. So this is a behavior of 3 persistent method. So it will be the first method, one persistent method, it will be continuously sensing, and when the medium is free, it will transmit. Next, it will be sense, randomly it will sense and wait, then it will transmit. In P persistent method, continuously it will send, and after that, for some time slot, it will be, it will not transmit, and after some time slot it will start transmitting. So it will wait for a, it will when the medium is idle, with a probability P it will send and it will wait for a probability 1 minus Q. So this is a flow diagram. The first case, if the channel is busy, then it will go. If it is idle, it will transit. Here, if the channel is busy, it will wait some random time, then it will send. So in P persistence, if the channel is busy, it will go for some back off process. If it is idle, it will wait for some probability, then wait for a time slot, then again it will send. So next one is carrier sense multiplexes with collision detection. So in this method, a station monitors the medium after it sends a frame to see if a transmission was successful. So in this carrier sense multiplexes with collision detection, after sending, it will monitor the medium whether any collision is occurring. If no collision is there, no problem. If any collision is occurred, the frame is resent again. So here the A is sending the information, and it is at the time T1, A is sending the information. At the time T4, the carrier, the C is sensing the medium, and since it is not getting the data from A, so it is thinking that the medium is free, so it is also sending the data frame. So both get collided, and the frame is lost. But since the medium is continuously monitored by A and C, they know about this collision. So that is collision detection. At the time 1, A has executed its persistent procedure and starts sending the bits of its frame. At the T2, station has not yet sensed the first bit of A. So C executes its persistent procedure and start sending the bits in its frame. So which will propagate from left to right. The collision occurs after a time T2. The station C detects a collision at T3 when it receives the first bit of A's frame, and the station C immediately aborts its transmission, and the station A will detect the collision at time 4 when it receives the bits from C. So when looking the figure, A transmits for the duration T4 to T1, and C transmit T3 to T1. T3 to T1. So due to this collision, that particular transmission is aborted. Minimum frame size for CMS, for carrier sense multiplexes collision detection to work, we need a restriction on frame size. Okay, so there must be some restriction on frame size. Before sending the last bit of the frame, the sending station must detect a collision. If any, it must abort the transmission. This is because the station, when the entire frame is sent, does not keep the copy of the frame. Why we are doing so means, after sending, the particular station is not keeping the copy of the frame, and it is only monitoring the line for collision detection. So the frame transmission time TFR must be at least 2 times the maximum propagation time. Okay, so here A is sending the frame, and here C is sending, and at this point the collision is occurring. Okay, and this is a transmission time of A, and this is a transmission time of C, and at this place it is detecting the collision, and at this place this A is detecting the collision. Flow diagram for carrier sense multiplexes with the collision detection. So first station is sending a frame. First it is making that first transmission as K is equal to 0, and it will be using any one of the persistence method for sending. Either it may be 1 persistence, and non-persistent, or P persistent. So after that, it is checking for any collision. It is transmission is done. So after transmission is done, or if any collision is detected, next it is going for checking any collision detected. If there is no collision, then it is success. If collision is detected, then it is sending a jamming signal to abort that transmission, and it is increasing the K value, now attempt value. Then it is checking for the maximum attempt. If the K value is if K value is greater than the K max, it will abort. If it is less than K max, then it will wait for some random time, that is back of time. Again, it will do the same procedure. So next one is carrier sense multiplexes with the collision avoidance. So the collisions are avoided through carrier sense multiplexes collision by collision avoidance by 3 strategies. One is the interframe space, next one the contention window, and the third one acknowledgement. By using these 3, this collision is avoided. How the collision is avoided? Collision is avoided by interframe space, contention window, and acknowledgement. What is interframe space? First, collisions are avoided by deferring or stopping transmission even if the channel is found idle, or delaying the transmission even the channel is found idle. When the channel is idle, the station does not send immediately. It will wait for a period of frame called interframe space. Even though the channel may appear idle, when it is sensed, a distant station may be transmitting. So the distant station signal has not reached this station. The interframe space time allow the front of the transmitted signal by the distant station to reach this station. If after the interframe space time, the channel is still idle, the station can send, but it still needs to wait a time equal to the contention time. So the interframe space is also used to prioritize the stations. For example, a station that is assigned a shorter interframe space higher priority than contention window. The contention window is an amount of time divided into slots. A station that is already ready to send chooses a random number of slots as its wait time. Okay. So what is contention window? A contention window is a amount of time divided into slot. So a station that is ready to send choose a random number of slot as its wait time. The number of slot in the window changes according to the binary exponential backoff. This means that it is set to one slot for the first time and double each time the station cannot detect the idle channel after interframe space time. This is very similar to the pre-persistent method, except that a random outcome defines a number of slots taken by the waiting station. So one interesting fact about the contention window is that the station needs to sense the channel after each time slot. In contention window, after each time slot, the station has to sense the channel. If the station finds the channel busy, it does not restart the process. It is just to stop the timer and restart it when the channel is sensed idle. This gives priority to the station with the longest waiting time. So acknowledgement, which all the precaution we are sending, there is a possibility of collision. So in addition, the data may be corrupted during transmission. A positive acknowledgement and a timeout timer can help the receiver So the positive acknowledgement and the timeout timer can help to guarantee that the receiver have received the flame. So in carrier sense multiplexes collision avoidance, the medium is continuously sensed and it is found idle. Then it will be wait for some interframe space. Then it is a contention window. Its size is binary exponential. Then it will be sending. So flow diagram of carrier sense multiplexes collision avoidance. First it is started, then the attempt is made as 0. If the channel is idle, then it will wait for some interframe space time. Then still it is idle, then it will wait for some random amount of time. It will take some time slot, then it will send the frame and wait for a timeout. If acknowledgement is received, success. If acknowledgement is not received, it will increment the number of attempts and the K value is checked with the maximum value 15. If that value is greater than 50, the process is aborted. If not, again it will repeat the process. This is nothing but the flow diagram for carrier sense multiplexes collision avoidance. Okay.